Well, thank you very much for the invitation to speak. I think today's audience is about the most important audience I could talk to, or anybody could talk to about climate change, because I think you are trusted sources of information and an incredibly important conduit of correct information to the people who probably will decide the fate of the planet. There are people who are currently in K through 12 grades. So I am delighted to be able to have this opportunity. And what I'm going to try to do today is address 4 major questions. Okay, the first, and this is not because I think anybody in attendance needs convincing, but we all know people who do need convincing that climate change is actually happening, and very importantly, that it's due to us. It's human activities that are causing climate to change rather than natural factors. These are 2 of the major climate denier arguments, 2 of the major sources of misinformation. And it's important, I think, not just to know what the correct answer is, but why we know those are the correct answers, so that you can give that information to others, and ideally they will reach the same conclusion. Okay, so we'll talk about a couple of the major types of misinformation in order to dispel them. And then we'll talk about the climate change in the Great Lakes region. And the focus today will be on species and ecosystems. And so the first question, the first question is, how has climate been changing in the Great Lakes region? But right away, we want to ask, and have species been responding to that current or recent climate change? And they have, but not necessarily in the ways we would like. So we'll look at what's already happened, and then we'll look into the future and ask, how will species and ecosystems in our region be impacted by future climate change? We can answer question 2 pretty definitively. We cannot answer question 3 definitively because it depends on our choices about greenhouse gas emissions. They will be affected very differently if we seriously curtail emissions than if we continue on our current path. And so I think it's always important then to end with some indication of how we can make a better future actually become reality. So what can we do now to minimize the adverse impacts of future climate change? I'd like to start out with a 30-second video. The URL for this, it's publicly available video, is at the bottom. And this is a NASA Goddard Institute for Space Studies video that it simply converts land-based and ocean-based, surface-based thermometer readings into what are referred to as temperature anomalies. And what the colors represent is the temperature of that place on Earth during the 5-year period shown at the top, relative to that same place's average temperature during a 30-year period, more or less middle of last century. So what we're looking at is difference during this 5-year period in the temperature at a particular place relative to its same temperature during the middle of last century. And blue means at the 5-year period shown at the top, it was cooler than it was in 1950 to 1980. And of course, the warm colors mean that it was hotter than it was during the middle of last century. So let's see what temperature has been doing on our planet. And the years go by pretty quickly at the top. Okay, so that answers the first part of the first question. How do we know that climate has been changing? Our thermometers tell us incontrovertibly, absolutely zero doubt, that Earth has been warming, and a lot of other components of climate have been changing as well. And one of the things that is part of the answer to how do we know it is us and not natural factors is that the rate of temperature change, the rate of warming, is an order of magnitude faster than anything we have a record of. And we have basically an annual record of Earth's temperature for 800,000 years out of Antarctic ice cores. So this is a wholly different kind of warming. If something is happening but very differently than before, there's probably a different cause, and that is us this time. Okay, so let's think about what can cause Earth's climate to change. There are two major natural factors. I think a lot of the time when people say it's just due to natural factors, they would be hard-pressed to tell you what those natural factors are, but there are really only two. Solar changes in the amount of incoming solar radiation. That does change in a cyclic fashion and is responsible for past climate cycles. So solar radiation is a natural factor that humans don't influence. And volcanic activity is. The more volcanic activity, because of that ash cloud that gets put up into the atmosphere and blocks sunlight, the more volcanic activity, the cooler Earth gets. And then there are several, I'll just talk about the three major anthropogenic or human-caused factors that can cause Earth's climate to change. One is changes in greenhouse gas concentrations in the atmosphere. They're going up. We haven't figured out a way yet to pull them out of the atmosphere. We've just been putting them in. We have also been putting in teeny particles. Whenever we burn something, including any of the fossil fuels, or when we change climate so that wildfires become more common, for instance, we put little particles into the air. They stay suspended for weeks, months, years, and in general, they're called aerosols, and in general, block sunlight. So in general, that's our only cooling effect. And the other warming effect that we have is taking away Earth's biggest carbon sponge, which is our forests, and in particular, our tropical forests. So there are other kinds of land use change that we are doing that have small impacts on climate, but the big one that we're doing is taking away a carbon sponge and actually turning it into a carbon sink, because that wood then burns or decays and becomes atmospheric carbon dioxide. So how do we know, again, that current climate change is not due to natural factors? First of all, I would say right away that up until the Industrial Revolution, all climate change on Earth from the beginning of our planet was due to natural factors. We had not yet figured out how to do things that unintentionally actually have a huge impact on climate. So all these are climate cycles from Antarctic ice core data 1 million years ago on the left, present, today on the right. And what we can see pretty easily is that there are cyclic fluctuations in temperature. We are currently at a temperature that has occurred only 3 times in the last 1 million years. But what I want to show here is that all of the times when Earth's temperature increased, it increased because we got more solar radiation from the sun. And there are 3 things about our position in space relative to the sun that influence how much solar radiation we get: the shape of our orbit, the tilt of our axis, and where we are in that orbit when the northern summer occurs, all of which together create cyclic changes in solar radiation reaching the planet, and therefore changes in temperature. And all of the warming periods historically have been due to increases in solar radiation, not due to us. So all over the last 1 million years, all of those warming periods have been caused by increasing solar input. So we should definitely ask, have we been getting more energy from the sun recently? And the answer is actually the opposite has been happening. For the past 70 years, while Earth has been in its most rapid warming phase that we're currently still experiencing, energy from the sun has actually decreased. The red line, so here's the last 70 years or so, red line is Earth's temperature. That's when in the video, a lot of oranges and reds started to appear, particularly in the high northern latitudes. But definitely global average temperature was increasing very dramatically, but we were actually getting a little bit less solar radiation over that time. So clearly, the only natural factor that could cause warming, and even though it's never caused warming as rapid as we're experiencing now, has been changing in the wrong direction to explain current warming. And if we look at the other natural factor, volcanic activity, it's actually been increasing, not decreasing. If we look at either large eruptions where the trend is not so clear, but if we look at the number of eruptions of any size, that has been increasing quite dramatically over the last 200 years. And remember that volcanic activity tends to cool the planet, not warm it. And so the bottom line is that both natural factors have been changing in a way that would actually lead to planetary cooling, not global warming. So really clear by process of elimination, that indicates it's not natural factors. We can look at the most important of the anthropogenic influences on climate, that is greenhouse gases. And what we see is that all three of the major ones, carbon dioxide being the most important, although not the most powerful. It's important because of its concentration. And methane and nitrous oxide all started to increase right when we understood how we could use fossil fuels to do work for us, the Industrial Revolution. And the increase has been dramatic for all of them. Okay, so bottom line, best estimate, in my opinion, quite clearly, the best estimate is all of current warming. 100% of current warming is due to human activities. About 80% of our influence is by burning fossil fuels. And about 20% of our influence on planetary warming is by deforestation. We may think of deforestation as for growing cattle or soy, something like that. That's true in South America, especially Brazil. But Indonesia has a huge deforestation issue. And there it's mostly for palm oil. Palm oil has not yet become a focus of attention for us. But certainly, if we lower demand, that would be a good thing for the planet. The other major argument, and in many ways this has become the primary type of misinformation, is that scientists don't agree about whether humans are really causing climate change. So I just want to ask, do scientists really disagree about whether we are the primary cause of global warming? This book, this is actually a high school science teacher, and she is holding a book that was sent to her free, just showed up in her school mailbox early in 2017, sent out by the Heartland Institute, a conservative think tank. And you can tell from the title why scientists disagree about global warming. It is focusing on that issue, and it's actually completely misleading. Okay, so let's ask, is there really serious disagreement? First of all, if you look at published papers by the experts, people who know the most about climate and how climate works, the climate scientists themselves, who are the experts, over 99% of them say in their publications that it's clear that humans are the main cause of current climate change. And I would argue these are the people whose opinions count the most. They're the experts. Now, if you want to know what's really happening, you go to the experts. So that is as strong a scientific consensus as you get on anything. And if we look at it a different way and ask, okay, what about not individuals, but scientific organizations? And let's look globally. And there are at least 200 high-level leading scientific organizations who endorse the conclusion that humans are the primary cause, including, I think, the gold standard for science on the planet, which is the U.S. National Academy of 30 years now. It said humans are the primary cause. 28 years, the American Medical Association has said we're the major cause because it has not only effects on species and ecosystems, but on human health as well. And there are many, many other high profile, very highly respected scientific organizations. Like I said, over 200, a few more are listed here. Well, that doesn't necessarily mean that there isn't disagreement, because there could be a roughly equal number of equally reputable scientific organizations worldwide that say, no, it's not due primarily to humans. So how many are there that hold a dissenting opinion? First, let's look at the global list as of 2007. There was one. And as of 2008, even the American Association of Petroleum Geologists membership said, look, the evidence is just so strong, it's a lie to say that it is not human. So bottom line is, for at least 15 years, there hasn't been a reputable scientific society anywhere on our planet that says that climate change is due primarily to something other than human activities. There is no disagreement among scientists, whether they're experts or in related fields. Okay, so those, I think, are important pieces of information if you're talking to somebody who could be persuaded, who holds the misinformation view, but would listen to information that would get her or him to change their mind. Okay, so let's turn now to our own region and ask, how's climate been changing in the Great Lakes region? If we look, once in a while, I'll abbreviate Great Lakes region as GLR, just in order to avoid using an extra line of text. That won't happen often, but GLR sometimes will be instead of Great Lakes region. And over the last 120 years or so, we have warmed by about 1 degree Celsius. And that rate of warming has, like the global rate, waxed and waned. And like the global rate, like you could see in the video, the rate of warming is increasing. Since 1975, we in the Great Lakes region have been warming 4 times faster than over the entire period since 1900. As a part of that warming is not just land-based, it's not just land surface, it's also water surface. We've got a lot of water surface in our region. And as of 2013, I have not seen a more recent version of this. It was clear that quite a bit of each of the Great Lakes had statistically significant surface warming. Lake Superior has been warming the fastest. The surface of Lake Superior has been warming the fastest. And we will talk about one of the consequences for fish in these ecosystems that is partly due to warming and partly due to the fact that warming, of course, means that the lakes are covered by ice less of the year. In fact, since 1973, ice cover has decreased by 71%, which is enormous. And actually, as ice cover decreases and ice is no longer reflecting sunlight, instead the water is absorbing the sunlight and converting it to heat, decreasing ice cover causes a positive feedback, makes the lakes warm faster, which makes ice cover decrease more rapidly. Okay, so temperature is one huge part of climate. There are many components of climate. The other really big one is precipitation. And on an annual average basis, since 1985, our region has been experiencing a bit of an increase in total annual precipitation, somewhere between 5 and 15%, except for parts of the western UP. Current drought conditions notwithstanding, there has been a general increase, but the big problem is that much of that increase in annual average precipitation has been in the form of extreme precipitation events. So massive deposition rates of water on the surface during very strong thunderstorms. Kalamazoo has had 3 once-in-a-century rain events in the last 8 years. So the kind of rain that comes down, a rain event where the water comes down so fast that it cannot soak into the ground, as fast as it's coming out of the sky, and so it stays on the surface, flows to a low point, and creates flooding wherever that low point is. Okay, what has been the national pattern of increase in severe precipitation events since 1958? Well, the biggest increase has been in the Northeast, but the second biggest increase has been in the Midwest. So we are experiencing that kind of climate change more than most parts of our country. And as a consequence, as I mentioned, if the water can't go into the ground, it flows down along the surface. And so the Great Lakes region has experienced extensive flooding. This is Ann Arbor, Grand Rapids, Kalamazoo in the lower left, and of course, East Lansing. And like I say, flooding has become kind of a routine thing in our region now, especially in spring, if it coincides with snowmelt. Okay, so we know that at least the two major components of climate have been changing in our region. Have species and ecosystems noticed? Have they responded in any way? And it turns out that one of the consistent responses pretty much everywhere in the world, and also in our region, is that plants are starting their spring activity earlier. For instance, bud burst, when they start to put out their first leaves, when the buds open and the leaves come out, that's happening 4 to 12 days earlier throughout our region than it was in 1950. Here's the national pattern with warm colors being shift towards earlier in the spring. Nobody really knows what's going on in our southeast at this point. But in our region, it's the shifts in spring timing for plants have all been earlier. And in general, that you can tell by the color and size of those recording stations, the data from those recording stations, that it's 4 to 12 days roughly earlier. Okay, so that's what in general plants are doing, although there's tremendous variation. Are other parts of our ecosystems changing in synchrony with plants? So is the whole ecosystem kind of staying together with its timing? And you can tell right away from the title on this slide, or the title sentence, that it's probably not the case. Migratory bird species whose arrival time from their overwintering grounds is crucial to being synchronized with their food sources. They are arriving on average earlier, but only 4.5 days. Remember, plants are speeding up 4 to 12 days. So here, this is from actually a long-term station, bird observation station in North Dakota. Each circle is a species of bird, and on the x-axis is the number of days after January 1st when it was first spotted, on average from 1910 to 1940. The y-axis is the day it first returned, 2000, on average from 2000 to 2012. And the dotted line is no change. It's arriving on the same day, same calendar day as it used to. Anything above the line is arriving earlier than it used to. Sorry, arriving later than it used to. Anything below the line is arriving earlier. And what you can see right away is most species are coming back earlier. They're tracking climate change to some extent. Problem is that most of our long distance and many of our medium distance migratory bird species are not arriving earlier enough. 4.5 days, for the most part, is not earlier enough. If spring is happening 12 days earlier. And so they're showing a response, but not enough of a response. Really only those species in the blue rectangle here are arriving earlier enough to actually be arriving at the same state of spring as they did last century. Killdeer is one that's doing a really good job of tracking climate change. It has sped up its arrival. It's a medium distance migrant. Wood thrush, a long distance migrant, is doing a horrible job. It's showing up when spring is much more advanced. And if you feed on something like insects, caterpillars, for instance, the problem is not when you arrive. The problem is when you've got a nest full of hungry teenagers 2 weeks or 4 weeks later, and the bugs have all, your prey, your food sources have all pupated, gone off and crawled under bark or somewhere to hide, and they're much harder to find. So it can be, that asynchrony can be a real problem, especially for long distance migrants. What about trees? Have our trees been responding? And the answer is yes, again, but not the way we wish they would. In the eastern U.S., it turns out only about a third of tree species have shifted their geographic ranges significantly northward in the last 30 years. It's a weird figure, but what we really want to look at are the green arrows. Green arrows, each arrow is a species of tree. And the green arrows are species that where their movement includes a significant northward component. First thing we see is it's not like all of the species are moving north. Only a third of these arrows are green. And even ones that are moving significantly north often are moving more significantly west. So it's not like our trees are tracking climate change by geographic shifts very well. And within our tree species, eastern U.S. tree species, conifers like white pine are doing a bit of a better job shifting northward and tracking climate change that way than our deciduous species like sugar maple. But even those that are moving significantly northward in the Great Lakes region are moving northward much more slowly than climate is moving northward. So again, not fast enough to keep pace with a moving climate. Okay, so we see that climate is changing, species are responding, although they have never experienced this sort of climate change before. So it's not surprising that they aren't showing the ideal response, and they clearly are not. They're in the right direction, but not fast enough, and often actually not even in the right direction. Okay, so how will future climate change affect species and ecosystems in the Great Lakes region? And this is our third question that I said originally. We can't answer definitively. We don't know, because the future depends on our choices. We know that with the Paris Agreement in 2015, almost all countries on the planet pledged to do what was necessary to limit warming to 2 degrees above pre-industrial temperatures, 2 degrees Celsius, and if possible to 1.5 degrees Celsius above pre-industrial temperatures. The problem is every country got to decide what it would do. It's individually determined commitment, and there's no enforcement mechanism, and most countries are not even coming close to meeting their Paris commitments yet. So we have envisioned and dedicated ourselves in principle to futures that are that include significantly less warming than the one we're at, but we haven't yet made the choice to act on that decision. Okay, that means the magnitude of future climate change is still quite uncertain, and it depends on our choices, primarily about greenhouse gas emissions. What I'd like to do is show what I think are the 3 main choices, or at least the 3 most discussed choices. There's almost an infinite number of possible futures, and I'd like to show them in relation to the historical levels of carbon dioxide in the atmosphere. This we get out of bubbles trapped in Antarctic ice cores. So carbon dioxide, starting 400,000 years ago and running to today, atmospheric carbon dioxide fluctuated together with the temperature cycle between about 180 and about not quite 300 parts per million. It never got above 300 parts per million until around 1950. The current level, this figure is 6 years old. So the current level actually is closer to 420, but we're already in uncharted territory in terms of greenhouse gas levels in the atmosphere. the business, what I call the business as usual future, means we continue to shift away from fossil fuels, but at our very slow rate, where we're actually burning more fossil fuels, but since we're using much more energy, the fossil fuels comprise a slightly smaller proportion of our energy portfolio. So we're shifting away in a sense, but we're still increasing atmospheric CO2 quite dramatically at about the rate we have been. And if we do that by 2100, these are predictions for 2100, atmospheric carbon dioxide gets to about 950 parts per million. And that would cause somewhere around a 4.5 degree rise in temperature relative to prior to the Industrial Revolution. That would be way hotter than Earth has been for probably 50 million years. If we meet the basic Paris Agreement, then we would prevent carbon dioxide levels in the atmosphere from exceeding 550 parts per million, still a lot higher than today. And as a consequence, we would probably limit warming to about 2 degrees above pre-industrial. Another one that is talked about not nearly enough, in my opinion, I call, nobody else does, but so if you use this term Paris extended, I don't think anybody's going to know what you're talking about, but I had to call it something different than Paris Agreement. It is the future that would limit warming to 1.5 degrees Celsius. And in order to do that, we'd have to stabilize atmospheric CO2 at 450 parts per million roughly. And remember, we're at close to 420 already. Okay, so what I will try to do now is, where possible, ask about how Great Lakes region species and ecosystems, and also our climate, would be impacted by a business as usual future, a Paris Agreement, and where possible, a Paris extended future. These are not all necessarily included in a particular study, so sometimes it's not possible to compare them. But I'll limit the examples to ones where at least two of these can be compared. Okay, first of all, if we want to limit warming to 1.5 degrees Celsius, if we want to make what I call the Paris extended future actually happen, we need to start reducing greenhouse gas emissions very dramatically right now. Okay, we can't wait any longer. If we want to have a 2/3 chance of keeping warming below 1.5 degrees C, it's not possible to make sure that we have 100% chance of keeping warming to 1.5 degrees, because there still are things about the climate system, especially positive feedbacks in the climate system, sort of runaway climate change, that we don't understand well enough yet, and so can't be sure that any reduction will actually make sure that we stay below 1.5 degrees. But if we want to give ourselves a 2/3 chance, then we have to start reducing greenhouse gas emissions dramatically and reach globally net zero emissions by 2040. If we want to give ourselves 50-50 chance of keeping warming under 1.5 degrees, we need to reduce emissions so that we become net zero by about 2055. If we want to give ourselves a 2/3 chance of not exceeding 2 degrees Celsius by end of century, then by 2070, we need to be carbon neutral. All of those require dramatic and immediate reductions in greenhouse gas emissions. And we can do it. We just haven't decided to do it yet. So right now we're heading towards a very unpleasant future. That's the business as usual future. Given that countries are not meeting their Paris commitments, I don't think there's any real reason to believe that we are, to think that we are on a pathway yet that would get us to much below 4.5 degrees warming. They're possible, but I don't think we've taken any action yet that suggests we're heading towards that better future. So we're heading towards a very unpleasant future, sorry. But we can still change course. We've got we'd have the capacity to leave our children and grandchildren a world that's livable, but we haven't chosen to do that yet. Okay, so the business as usual future will be imaged on the right. It's also known as RCP 8.5. These are predictions from the American Geophysical Union starting in 1985 of global temperatures. And on the left is the Paris Extended Future, also known as RCP 2.6, where we limit climate change to 1.5 degrees by the end of the century. So let's just look at what these two different futures would be like. And the years are going by. It starts somewhat in the past just to verify that the models can predict what's already happened. So by mid-century, it's already a very different planet under the two emission scenarios. But even more so, of course, by end of century. Okay, and you can download this video from YouTube if you like. Those are two incredibly different worlds. And our children, grandchildren, great-grandchildren will inhabit something that is either one of these or something maybe in between. The one on the right is one that almost certainly will have massive crop failure, water shortage, disease spread, floods, droughts, and as a consequence, conflict, armed conflict, and my guess is nuclear conflict. The one on the left is one that would feel mostly like today, not a whole lot different. But the one we're heading towards, just by lack of action, is the one on the right. Okay, let's ask what is the future climate change likely to be for the Great Lakes region under different emission scenarios. And first, almost always, the target date will be 2100 or close to it. And one of the scenarios will be the business as usual scenario. Okay, so let's take a look first at the pathway we're currently on. By 2100, under business as usual emissions, summer temperature in the Great Lakes region on average would be 7 degrees C or about 13 degrees Fahrenheit warmer than today. So the scale here is temperature change relative to pre-industrial, and it's pretty consistent warming throughout our region at about 7 degrees Celsius, which is enormous. Under the Paris Agreement, that increase in average summer temperature, which I think is the most important part of the year, it's the growing season, would be the increase would be reduced by about half. So instead of 7 degrees warmer on average for summer, it'd be about 3.5 degrees Celsius or about 6.5 degrees Fahrenheit. Okay, so temperature would certainly be more hospitable under Paris Agreement and even more so under Paris Extended, although I don't have a map to show that. What about precipitation? Summer precipitation under business as usual for our region is predicted to decrease by about 10%. Precipitation is harder to predict than temperature for sure, but there's pretty strong consensus on about a 10% decrease in precipitation under business as usual. That combined with the 7 degrees Celsius, 13 degrees Fahrenheit increase in temperature probably would be disastrous for our ecosystems, both natural ecosystems and agricultural ecosystems. Again, the Paris Agreement reduces the bad change by about half. So instead of a 10% decrease in summer precipitation under Paris Agreement, we have maybe a 5% on average decrease in summer precipitation. That combination of smaller increase in temperature, smaller decrease in precipitation would make it much less stressful future for species, ecosystems, and of course also for us, for humans. That's average summer temperature and precipitation. But For ecosystems and for humans, what will matter more than changes in averages is changes in extremes. And one of the types of extreme temperature we can have is a record hot summer. So question is, under the different emission scenarios, what proportion of Great Lakes summers are predicted to be hotter than what is today our record hot summer, which I think for most of our region was 2012. Okay, so by 2070, it's actually the last 3 decades of the century, 2070 to 2100, under business as usual, 90% of our summers are predicted to be hotter than we've ever had, hotter than our current record hot summer. Here's a global prediction under the business as usual scenario. Red, which is the predominant color in the Great Lakes region, indicates 90 to 100% of future summers will exceed what historically is the record hot summer. Would the Paris Agreement make any difference for us and for the rest of the world? The answer is huge. It would make a huge difference. As few as 10% of summers would be hotter than our current record hot summer. So the predominant color in our region now is light green, which is a big range, 10 to 50%. But still, most of the red disappears off this map. Tropics still, number of record hot summers, but for our region, it certainly would be beneficial. With warmer temperatures and less precipitation, of course, we get the most deadly extreme event for life on land, which is drought. It took 3 billion years for life to move out of water and onto land, and the huge barrier was desiccation. So drought is still the most deadly extreme weather event for land-based life forms. And here we'll look not at business as usual, but more at a 3-degree warming, which is what would happen if all countries actually met their stated emissions reduction commitments. So with 3 degrees warming, it turns out that in our region, as in many places on the planet, the severity of droughts would be increased by 3 to 5-fold. That's the red on this map. So anywhere that's red sees a 300 to 500% increase in drought severity under 3-degree warming. Under 2-degree warming, the basic Paris Agreement, there's a lot of blue, which is actually a decrease in drought, and an awful lot of, in our region, an awful lot of really no change. So all in all, in our region, Paris Agreement would keep drought severity at about where it is now. Okay, so those are some of the major changes that we can expect in Great Lakes region climate, and how those changes are influenced by our decisions about greenhouse gas emissions starting today. If we wanted to predict effects on species and ecosystems, I think the easiest set of ecosystems to make confident predictions for are aquatic ecosystems. And it's likely that climate change will strongly impact our aquatic ecosystems. One of the very easy rules for both ponds and lakes, or still water aquatic ecosystems, and running water, rivers, streams, and so on, is that if you're something that likes warm water, you'll probably be a climate winner, because both of those types of aquatic ecosystems will warm. But if you like cool or cold water, you're likely to be a climate loser. Okay, and that's true for fish and everything else. We'll focus on fish. We ask, well, what species of fish are likely to be climate winners because they're like warm water? Carp, bluegill, catfish, white perch, not exactly the species that are considered sport fish or form the basis of our tourist industry or anything. Climate losers includes all of those. So whitefish, all of the trouts, walleye, all of the salmons are likely to be substantial climate losers because they are deep water, cold water, or cool water fish. Okay, in addition to just the changing temperature of the water, one huge impact that I think is not being discussed enough, basically almost not at all, is the impact on our sport fish, on our deep cool water fish, by an increase in the length of what's called the summer stratification period. Briefly, let me go through what happens in temperate lakes that are 30 feet deep or deeper each year. Water has a weird property where it is most dense at the temperature of 4 degrees Celsius. Ice floats. Ice is 0 degrees. It floats because it's less dense than water that's 4 degrees, not yet frozen. So in the winter, we're 0 degrees at the surface, 4 degrees in deep through much of the profile, but certainly in the deep. In the spring, the sun melts the ice. As soon as the ice goes, the surface warms up to 4 degrees. Now the lake is the same temperature and therefore the same density from top to bottom. And at that point, wind blowing across the surface can push surface water, which has a lot of oxygen, down into depths and thereby replenishes oxygen in the deep waters. So there's a spring turnover of the lake. Water comes up from deep and brings nutrients to the surface. But for our purposes, what's really interesting is that oxygen gets mixed down and the deep waters get replenished in oxygen in the spring. But pretty quickly, the surface becomes warmer than 4 degrees. And now it's less dense than the deep water. And the wind can no longer push less dense surface water down through more dense deep water. And at this point, the lake becomes layered or stratified. And it stays stratified until the surface cools down in the fall, when once again it gets to be the same temperature top to bottom, and the wind can push oxygen-rich water down into depths. So the problem is that oxygen mixed down during the spring turnover has to last anything that lives in these deep waters until the fall turnover. And that oxygen is in these deep waters. And the problem is that the length of that summer stratification period is increasing. Okay. And that's because lakes are warming and ice cover is on the lake for less time. The spring turnover is happening earlier and the fall turnover is happening later. This is annual ice cover on Lake Michigan. The average for 1973 to 2022 is the blue line. This past year, 2023, is the red line. And one thing that you can see clearly is that ice started to form on Lake Michigan much later than normal, and it disappeared much earlier than normal. The fall turnover occurs, the spring turnover occurs when the ice disappears. And then the fall turnover occurs when the ice reappears, or just before the ice reappears. So the spring turnover is getting earlier by about a month. And when it used to be early May, now it's early April. And that means that the oxygen is now going to have to last at least a month longer. What is the predicted future lengthening of the summer stratification period? Dramatic increases for all of the Great Lakes under business as usual. So almost 3 months longer by end of century for Lake Superior, 2.5 months for Lake Ontario, roughly 2 months longer for the other 3 Great Lakes, including Michigan, Huron. That, to me, it seems unlikely that the same amount of oxygen that's always getting mixed down in the spring will be able to last 2 to 3 months longer. And I think that we're headed towards business as usual is a future that will include common and very large-scale suffocation events, fish kills, of the fish that live in deep water. They just run out of oxygen. Paris Agreement, the summer stratification period would still increase, but a lot less. So instead of 3 months, it's about 1.5 for Lake Superior. It's about a month to a month and a half for Lake Huron, Michigan, and Ontario. I don't know. I'm not an expert in sort of fish physiology, but I think certainly that would have a much better chance of preventing these large-scale suffocation events. If we look in aquatic ecosystems that are flowing ecosystems, rivers and streams, and in this case, I was looking at the Kalamazoo region in particular. The big effect of climate change is, well, the streams will warm, streams and rivers will warm, but a huge thing is they're also going to have different flow regimes. So it's going to make river flow more variable. There will be more high flow days, especially in winter and spring. Under business as usual, the prediction is that we'll have about 85% more high flow days by end of century. Under Paris Agreement, there's an increase, not quite as much, but still an increase in high flow days. I think the most dangerous flow change for river stream species are the days when flow is very low. So summer, low flow days during droughts and so on, when the water gets quite warm and also contains less oxygen. These are the killer days in terms of flow. Business as usual, the prediction is that in our region, low flow days will increase by about 50%. And here's the big benefit, I think, for flowing water, Great Lakes aquatic ecosystems, is that the Paris Agreement would prevent an increase in low flow, those really deadly days. Okay, if we look at trees, I'll say that the predictions about individual trees and forest composition are they're being refined as we speak. So there is no real strong consensus about the effect of climate change on forest composition or individual species at this point. Probably will be in a year or two. But one thing we can ask is, what about our fruit trees? Under business as usual, a big important thing for fruit trees is having enough of a chill period to actually prompt flowering and fruiting in the spring. And that basically boils down to how many hours below freezing, how many days, how many hours below freezing does an apple tree experience. So if we look at the predicted change in the number of days below freezing, by 2090 under business as usual, the prediction is about 50 days, 50 fewer days below freezing. In our region in Michigan, there are many crops that need extensive chill periods. The 50 fewer days would involve probably about a loss of about 500 chilling hours. And that may well prevent cherries, apples, and blueberries, for instance, from meeting their dormancy requirement, and it may not be possible to grow them in Michigan in the future. Under Paris Agreement, there's still a decrease, of course, in the number of days below freezing, but it's a lot less dramatic of a decrease. So under Paris Agreement, instead of 50 fewer days, it's about 20 fewer days. And that probably means that the chilling requirements will still be met, at least in parts of our state. And so cherries, apples, and blueberries will still be crops we can grow. One of the things that's also an sort of unrecognized but very serious consequence of climate change is what are called false springs. And they can be very damaging for fruit trees and pretty much any plant, and also insects. And a false spring occurs when in February or even January, you get abnormally warm temperatures for long enough that plants get fooled and they start to develop, they think it's spring, and they start to develop their leaves and possibly even their flowers, and their delicate tissues, which really are the young leaves and the flowers, get developed to the point where they're actually quite vulnerable to a frost, and then a frost happens. And so you get apple blossoms with snow on them that end up being incapable of producing fruit. So false springs are actually becoming a lot more common, at least in they haven't been tracked in many places, but in Illinois, they're now 7 times more common. And that's a huge problem for fruit trees, but also for other kinds of plants, also for insects. I want to just mention that one of the other components of climate change, again, not something that's getting any attention that I have seen, but I think it's a real concern, is that the fact that autumn is extended. Winter isn't starting as soon. Ice isn't forming on the lakes as soon. Can be an incredible problem for Great Lakes region or Michigan insects. Okay, why? Because they go into their version of hibernation, it's called diapause, by noticing that the days are getting shorter. So but day length isn't affected by climate change. So in the future, insects are going to be going into diapause, their version of hibernation, at the same time as they always did. But the fat reserves that they had built up will be used up more rapidly because the fall temperatures are higher. And that will cause them to use their stored reserves faster and possibly starve before spring comes around and they can start feeding again. So I think rapid emissions reductions, Paris extended, would have an incredibly beneficial effect on Great Lakes region insects and, of course, then on anything that relies on it, including fruit trees and birds, for instance, insectivorous birds. The Audubon Society has done a great job of predicting the fate of, I think it is almost 370 different bird species east of the Mississippi, and even has county by county predictions about the consequences of 3 degree, 2 degree, and 1.5 degree warming for local bird species. And it turns out that for Ottawa County, under 3 degree warming by end of century, 16 of our local bird species would become highly vulnerable. Okay, most of them are pictured here. If we limit warming to 2 degrees, then instead of 16, 5 species become highly vulnerable. And if we limit warming to 1.5 degrees, only 2 species. So certainly local birds, and I understand you may go on a bird walk later today. Our local birds would be dramatically helped by limiting warming to 2 or even 1.5 degrees. All of those data are on the Audubon website, which is called Survival by Degrees. You can look up individual species and individual local regions if you want. Okay, so that gets us to the final question. What can we do? I mean, we are in a climate crisis. There's no question. There is no time for delay. So question that we should always end with is, what can we do to help prevent warming from exceeding 1.5 degrees or, if necessary, exceeding 2 degrees? The good part of the answer is we've got all the tools we need. We can change the future by implementing solutions that we already have available. I'll go through some very briefly, starting with the one that I think is the most important, and that is be a climate voter. Make climate change and encourage your students to the extent that you can to make climate change their major voting issue. There is no issue that is more important. All of the other social issues, many of which I feel passionately about, are all going to be influenced by climate change as well. So all social justice issues will be influenced dramatically by our climate change decisions. So encourage students to vote, and to the extent you can, encourage them to be climate voters. So we need to get people in place who will make the policies happen that provide a decent future to our children, grandchildren, and great-grandchildren. But until the right people are in office, we need to demand that those who are making policy make the right policy, the sane, the humane, the reasonable policy. We have, in Michigan, we have a pretty good policymaker we have pretty good policymakers in the governor and our senators. Depends who your representative is. Some are good, some are not. But we need to, and we have a president who at least is interested in doing something about climate change, unlike his predecessor. So we're doing something, we're just not doing enough. And we need to call on our current policymakers to do more. What do we need in particular? We need to switch over from fossil fuels to smarter sources of energy. We need to be getting 80% of our energy from smarter sources. I would argue 100% if possible. So at least 80% by 2040 from wind and solar are our two best options. Could we provide enough energy by either of these or by both of them combined? And the answer is either alone could supply all of the energy that humans use over the entire planet in all forms, multiple times over. The global potential of 3 different existing solar technologies is 100 times everything humans use. We have to convert things to electricity that are currently running on fossil fuel. But if we do, we can provide green electricity out the wazoo. We could do the same using only wind, only onshore wind, gives us 40 times all of the energy that we need. And the U.S. would be a big producer of both of these. Third thing we can do on an individual level is start reducing our own carbon footprint, and in particular, our household carbon footprint. Next time you buy a car, get an electric vehicle or get a plug-in hybrid that gets much higher gas mileage. Shift your diet to, actually the biggest thing is remove beef and lamb. If you are still a meat eater, substitute chicken. And that will actually fairly dramatically reduce your dietary carbon footprint. And the biggest thing you can do in terms of household energy expenditure is turn your thermostat the way you don't want to. Degree a week and nobody will notice. Okay, and a very important thing is talk to people. You've got an incredibly important audience. Policymakers, current policymakers have learned, those who don't want to do anything, have learned how to tune us out. They have not learned how to tune out young people. And the 2 voices that we absolutely need, that will be crucial for changing the future we're headed toward, are young people's voices and the faith community voice. So you are a conduit of information, a trusted source for people who need to know the truth and need to talk about it with others. So talk about what you know about climate change because there's so much misinformation, with friends. That's going to be easy. Talk about it with coworkers. Maybe you've got other teachers that just don't know yet what is the correct information. Especially talk to people who just don't think the same way. People can change their minds. And more than 2/3 of Americans are worried about climate change. So they'll be receptive. And I think the most important audience you can reach are your students. They're incredibly important for the future of our planet. I think you and your students, it's great. All of us could join what I call climate truth organizations. The Sunrise Movement is the youth climate movement. I think this is the climate action group that has the best chance of changing the future because it's young people. And they are willing to do things like go and sit in Nancy Pelosi's office and so on. So students especially, I would encourage them to join the Sunrise Movement. For older people, Citizens Climate Lobby is a great organization that works much in a much sort of gentler fashion, trying to get carbon fee and dividend legislation passed. I would encourage all of us, and to the extent, again, that you can, encourage your students to get out and show the powers that be what they think. So participate in public actions. I think the boots on the ground, what we need is not just hands-on, we need feet-on exercises, activities where large numbers, massive numbers of people get into public view saying we need to change things. You need to stop stealing our future, which is what we're doing to them. Okay, remember that we're in a climate emergency. We need to act right now to start dramatically reducing greenhouse gas emissions. And because in the Great Lakes region, just like the rest of the world, we are already in a climate emergency, and you don't delay in addressing an emergency. The future is still undetermined. We have the tools to change from the future on the right to the future on the left, but we need to start using them now. And I think what we could aim for is helping our students become at least some of the people who actually save the planet. It's a horrible position they've been in, but it's a what would you rather say in looking back at your life towards the end of it that, hey, yeah, I helped save the planet. That would be a wonderful legacy to leave. Okay. Thank you very much